Chapter 1. No, chapter 14. It's a new semester, but same book. Okay, chapter 14, Chemical Kinetics. So this first section is entitled Catching Lizards, and the author talks about how his children have an unusual way of catching lizards. They run around with large cups of ice water and throw the ice water on the lizard. The lizard becomes very cold suddenly and can't move and is easy to catch. So how does that relate to chemistry? Well, lizards and other cold-blooded creatures are ectotherms. So they're animals whose temperature, their body temperature, matches the environment's temperature. They can't self-regulate their temperature. It depends on the outside. So the cold water causes the lizard's body temperature to drop. Temperature affects the rate of chemical reactions. So the rates of all the reactions occurring in the lizard's body slow down, and so the lizard cannot move as quickly as it can when it's warmer. And so the lizard is slow and lethargic and easy to catch. So chemical kinetics is a study of the different things that affect how fast chemical reactions occur. Temperature is one of those things. The ability to control the rate of a reaction is very useful and sometimes critically important. Examples are rate of fuel combustion. So you want the fuel in your car to burn fast enough but not too fast. You want the fuel in a spaceship, a rocket, to burn fast enough to cause the ship to lift off, but not too fast, which would cause it to explode. Your body is teeming with chemical reactions that are occurring. Those chemical reactions are often controlled by enzymes, and the speed at which they occur and whether they occur or not is critical to life. Understanding chemical kinetics also gives us insight into how these reactions occur, and that gives us more control over them, make them do what we want them to do.